Good morning. Welcome to 5G Communications course. Today we are going to discuss about evolution from 1G to 5G. Myself, I am Murali, working as assistant professor in the Department of ECE, Institute of Aeronautical Engineering. The course outcomes of this course is at the end of the course, students should be able to recall the requirements and key functionalities of 4G, LTE, long-term evolution, 5G NR, new radio technology used in 5G communications. Topics to be covered is from 1G first generation, second generation, third generation, fourth generation, fifth generation. Now we are in the 5G communications. These are the topic learning outcomes. Understand the fundamental concepts of mobile communication at the time of starting. Identify the key features and limitations of 1G to 5G. Analyze the evolution of services and applications. Discuss the improvements in latency, bandwidth, and connection density. Evolution from 1G to 5G. In 1G, at the time of starting, they invented in 1930 afterwards 1G, 2G, 3G. 1G was invented in 1980 to 90, 3G and 4G 2000 to 2010, 5G is 2020 to 2030, and 6G and so on. In 1G, it is facilitated with only basic voice and text messages. Next generation is users can add images, videos. In 5G, it is introduced ultra high definition and thermal. From generation to generation, the technology is improving. First generation, these phones were the first to be used in 1982, completely in 1930. It was used for voice messaging. 1G phones is used only for voice and AMPS, advanced mobile phone technology. The AMPS system used frequency modulator with channel capacity of 30 kHz and a frequency band of 824 to 894 MHz, and FDM frequency division multiplexing is used. In the 1G, technology involves MTS, mobile telephone system, AMTS, and MTS, push to talk. Those are one of the technologies we are using in 1G. And the primary characteristics of 1G mobile phones is 2.4 kbps speed, enables voice calls in one nation, and large phone size. The phone size is large in 1G. Next, from generation to generation, we reduce the size of the device also, and poor handoff, and voice quality is somewhat poor, and sufficient spectrum that more. And the limitations is low capacity and limited coverage, unpredictable handoff leading to dropped calls, poor voice connectivity with heavy noise interference, and there is no security in 1G mobile phones. Only that means 1G mobile phones is used only for making calls. In 2G, the term 2G second generation came into the picture. GSM, Global System for Mobile Phones. GSM means Global System for Mobile Phones. GSM stands for Global System for Mobile. GSM phones. GSM phones is introduced in 1980. It is used for voice communication. It was digital signals, and the frequency range of 2G is 30 kHz to 200 kHz, and the various versions is 2.5G. This is the image of 2G phones, second generation phones. And the technologies used, coming to the technologies used in 2G is GSM, Global System for Mobile Communication, and CDMA, and digital AMPS, digital version, GPRS, General Packet Radio Service, EDS, Edge Technology, improved. And primary characteristics of 2G and 5G. 2.5G. 2G stands for second generation. Data transmission rate is 64 kbps, or achieved through digital signals, enabling services, text messages, picture messages, MMS, incapable of dealing with complicated data, video, and mobile phones to function, and network coverage in particular area. And continuation, those are all of the characteristics of second generation. GSM technology was constantly developed to give data services, which resulted in advanced technology 2G and 3G. Calls are made available. Send and receive emails. Their closing speed is 64 to 1 kbps, 1.4 kbps. Camera phones, 6 to 9 minutes it will take to download, 3 minutes MP3 music. And disadvantages of 2G is low data speed compared to 3G and later generations, limited internet access, not suitable for multimedia rich applications, voice quality improved, but still sometimes degraded in poor coverage areas. Roaming was possible with the GSM phones and all standards. And this is the third generation mobile phone. 3G was introduced under the IMT 2000, International Mobile Telecommunications 2000. It uses the technologies WCDMA, wideband code division multiple access, and CDMA technologies. Operating bands is 850 MHz, 900 MHz, 1800 MHz, and so on. Uses circuit switch and packet switch. Supports both voice and data. In 3G mobile phones, it supports both voice calls and data internet that know. Channel bandwidth is 5 MHz and 20 MHz that know. The primary characteristics of 3G mobile phone speed is 384 kbps to 42 Mbps. Services are voice calls, SMS, MMS, multimedia services, internet access came into picture, and email, browsing, video calling, video streaming, mobile TV, and multimedia messaging, digital signal transmission. These are all the characteristics of 3G. More secure than 1G and 2G. Better spectrum efficiency compared to earlier generations. Global roaming supported through GSM and UMTS standards. Handsets sleeker and smaller than 1G and 2G with color displays, cameras, and multimedia functions. And the limitations of 3G are high power consumption, shorter battery life is short, network rollout was costly, slower adaptation in rural areas, speeds not sufficient for high definition streaming or emerging data heavy apps. Latency was lower than 2G but still not ideal, 100 milliseconds. This is the 4G mobile phone. 4G mobiles was designed to provide high speed internet and all internet protocol based communication. Unlike earlier generations, 4G completely abandoned circuit switching, worked on packet switching technology. The main standard for 4G was LTE, long-term evolution, and its enhancement, LTE advanced. 4G uses the technologies OFDM, orthogonal frequency division multiple access, for downlink, and SCFDMA, single carrier FDMA for uplink. Typically operated in 700 MHz to 2.6 GHz frequency bands with flexible channel bandwidths 1.4 MHz to 20 MHz up to 100 MHz in LTE advanced. Its primary characteristics. The primary characteristics of 4G mobile phones is data speed is 100 Mbps for mobile users, up to 1 gigabits per second for stationary users, much faster than 3G. Enabled real-time HD services, all internet pro IP network, supports voice over IP, Vivo LTE, voice and circuit switching. Services is high definition video streaming, seamless internet browsing, fast downloads, online gaming, mobile TV, social media apps, cloud storage, video conferencing with high quality, better security with advanced encryption compared to 2G or 3G. Spectrum efficiency greatly improved with OFDM and MIMO technologies. Handset is slim, touch-enabled smartphones. The 4G handsets are slim and touch-enabled handphones with larger screens and GPS, Wi-Fi, wireless fidelity. Wi-Fi stands for wireless fidelity. And sensors we are using GPS, global position systems. That all is there. 4G mobile phones are slim and GPS, wireless fidelity, and sensors is there in the 4G mobile phones. The limitations of 4G is high power consumption due to constant data connectivity, coverage gaps in rural areas and remote areas, especially at launch, network congestion when too many users share the same cell. That means in mobile communication, it is in a hexagonal shape. Like this, the signal will be there. This is called as frequency reuse. We are going to use the same frequency in some other location. That is called as frequency reuse. Frequency reuse concept. Why we are using hexagonal shape? The shape of the cells means if you use circular terminals, there will be chance of overlapping. Will be there. But if you use hexagonal means there will be no overlap. If you use hexagonal shape means there will be no overlap. This is called as hexagonal shape. Hexagonal shape. The shape of the cell is hexagonal. We use hexagonal means there will be no overlapping. Latency is 30 to 50 milliseconds, lower than 3G, but not via 5G. Network congestion when too many users share the same cell. If too many users share the same cell, there will be network congestion, gaps in the rural areas, especially at the time of launch. And 5G mobile phones. 5G mobile phones are the latest generation of mobile technology designed to deliver ultra high speed, extremely low latency, and massive device connectivity. Unlike 1G to 4G, 5G is not only for voice and data but also for powering IoT, smart cities, autonomous vehicles, and advanced applications. 5G uses technology such as millimeter wave technology, and 5G uses the technology millimeter wave massive MIMO. MIMO stands for multiple input and multiple output. MIMO stands for multiple input and multiple output. And reinforcing and OFDM technology, orthogonal frequency division and multiplexing, and network slicing. It can operate across low band below 1 gigahertz and mid band 1 to 6 gigahertz, and high band ranges from 24 to 100 gigahertz. Frequency range with channel bandwidths up to 400 megahertz and beyond millimeter wave. In our India, 5G is launching slowly. Where they are increasing the mobile related companies. They are increasing the 5G signals and they are installing the towers. Now 5G mobile phones they are selling, and because they are increasing the products. Its primary characteristics of 5G is data speed is up to 10 gigahertz. Theoretically, typically 1 to 3 gigahertz is real use. Latency is as low as 1 millisecond, enabling real-time application. Services of 5G is EMBP, Enhanced Mobile Broadband, UHD or 8 kilobit, AR, Augmented Reality. AR stands for Augmented Reality, and Virtual Reality. AR stands for Virtual Reality. Augmented Reality and Virtual Reality. URLLC, ultra reliable, low latency communication, self-driving cars, nowadays self-driving cars, and remote surgery, industrial automation, massive multiple input, billions of IoT devices we are using. All IP and cloud native enables flexible and virtualized network security, stronger encryption, and network slicing isolation for high security. Handsets are sleek smartphones with powerful processors, AI chips. AI stands for artificial intelligence. Nowadays, AI/ML is important. Artificial intelligence chips that we are using. And multi-lens cameras and large displays, 5G antennas they are using. Limitations: high deployment cost for infrastructure and spectrum, limited coverage and needs dense small users. High power consumption of 5G and impacts battery life. Device cost is more in 5G. In the evolution from 1G to 5G, those are the years. 1G was until 1980, 1990. Now we are in 2025G. And our new radio technology, we are using massive MIMO and beamforming. And like that, the technology is going from 1G, 2G. 1G was introduced in 1980, next generation, third generation, fourth, fifth generation. Now we are using 5G mobile phones. Some people we are using 5G mobiles. Technology to technology. In 1G, the services is only voice only. But in 2G, voice only, SMS, short media service, and multiple internet service. Internet came with picture in 3G, and voice over IP, HD streaming, and those are the speeds. We are from generation to generation, the speed is increasing. They are increasing the speed here. The 1G 2.4 kbps, 38, and 2 megabits per 1 gigabits like that. We are increasing the speed. Technology to technology, the speed is getting increased. And nowadays, without internet, there is no world. Without mobile phone, also there is no world. Everything is lying in the mobile phone. We are all doing all the things from morning to evening. And we are using internet and booking food, booking tickets, train tickets, all the things we are doing with the usage of mobile phone and internet facilities. And generation to generation, which techniques we are using. 1G uses FDMA technique, 2G uses TDMA, 3G, and 4G uses FDMA, and network slicing techniques that control VTS and limitations. Thank you for this session. Thank you. Today we completed the discussion on evolution from 1G to 5G technologies.
Like, share and subscribe. Hit the bell icon for more updates.